All right, hello, math fans. All right, so this is day 2 homework for chapter 4B, and it's basically more optimization problems. All right, so let's start off here. Number 20. The key to this problem is it's drawing the picture. Okay, this is actually a pretty difficult problem to set up, but this is 20. So it says the quickest route. Jane is 2 miles offshore in a boat and wishes to reach a coastal village 6 miles down a straight shoreline from the point nearest the boat. She can row 2 miles per hour, and she can walk 5 miles per hour. Where should she land her boat to reach the village in the least amount of time? So what we're doing here, math fans, is we're actually minimizing time. Okay, that's what they're asking. What is the least amount of time? Okay, so first of all, I need to draw a picture, and that's probably the hardest part of this whole thing. Here's a point here with the boat, and here's the shoreline. And her goal is to go between here and here. It's 6 miles. And the distance to shore here is 2 miles. Oops, I wrote 6 there. It's 2 miles. It's 2 miles. All right. So what I'm going to do here is this distance, x is the distance she should cover downstream in her boat. So I'm going to write this out. X equals the distance covered down, I'll say downstream or down the shoreline in her boat. So in other words, she's going to go this distance here, and so that's x right there. That's going down there, and then of course this is 6 minus x from here to here. All right, and let's see. So let's use a little Pythagorean theorem because it's a right angle right here. Okay, and if I use Pythagorean theorem, I get the square root of 4 plus x squared. That's that distance. All right, the distance actually she's traveling in her in the boat. All right, so 6 minus x is she's walking, how much she's walking down the shoreline, and x is the distance down the shoreline that was covered in her boat. All right, so and then of course 4 plus x squared is actual distance. I think I said that. All right, so let's set up a nice little friendly problem here. F of x is equal to the distance 4 plus x squared. So that's the distance traveled in the boat. So this is the boat, which is our hypotenuse here, plus 6 minus x miles, which is the distance traveled walking. All right. Now, that's in terms of miles, but we know the speed, so we can actually figure out the amount of the distance, right? We know the speed of each one of these. It tells you she can row 2 miles an hour. So this is miles, and if we divide this by number of hours, so 2 or miles per. So actually, I'm going to write it this way: miles per hour. And this is divided by walking is 5 miles per hour. Okay, and if you actually then calculate this out, each of these become hours. And that's kind of what we're doing here, math fans, right? Here it is, man. We're trying to minimize time. Okay, so if we have a function in terms of time, we're good to go. So if I simplify this, f of x, which is time, is equal to 4 plus x squared over 2 plus 6 minus x over 5. Okay, then we take the first derivative. Now we can use the quotient rule or you can just say 1/2 times that. Well, the quotient rule is pretty easy, especially when you have a constant on the bottom. So, as you guys already know, if I write this as 4 plus x squared to the 1/2 power, it makes it a lot easier. So we're just going to do that. We're going to say 1/2 times 4 plus x squared. So it's actually the bottom times the derivative of the top. So 1/2 4 plus x squared to the negative 1/2 times the derivative of the inside, the chain rule, times 2x minus the top times the derivative of the bottom, which is 0, all over the bottom squared, which is 4. So if we simplify all of this, and of course, let me do the derivative of this next guy here. Bottom times derivative of the top, so it's going to be plus 5 times negative 1 minus top times derivative of the bottom, all over the bottom squared. So it's 25. All right. So if we simplify this, I'm going to keep writing to the right-hand side here. I get x over 2 square root of 4 plus x squared, okay, minus 1/5. All right. So then I need, of course, set that equal to 0. All right. And I'm going to actually cursor down here a little bit because I'm running out of room. So you set that equals 0, so I'm just going to move that over. I get x 2 square root of 4 plus x squared equals 1/5. Cross multiply. And I get 5x equals 2 root 4 plus x squared. All right, I need to square both sides. Let's get rid of that radical. So I square both sides, and I get 25x squared equals 4 times 4 plus x squared. All right, and so I get 25x squared equals 16 plus 4x squared. And then I'm going to move that 4x squared over. I get 21x squared equals 16. And I get x squared equals 16 over 21. If I take the square root of both sides, I get x equals 4 over root 21. But in decimal, it's about 0.87. All right. Now, this is the deal. This is a closed interval problem. We don't have many of those, but it's a closed interval because she can roll the whole way, and or she can walk the whole way, right? So that's why it's a closed interval problem. All right, so what I want to do is I want to check the endpoints, and I want to check this x value that we figured out here. So if I do f of 0, okay, and remember x represents the distance she should cover downstream in her boat. So this means no boat. Okay, and then we have f of 6, which means no walking. And then we have f of our 0.87, which is our maximum. And we actually should check this too. Okay, 0.87, and we'll check, 0.7 and 0.9. And again, we're trying to minimize the time. So if you plug this back into the derivative equation, which is back over here, it's kind of a big problem to fit on this one screen. And you put 0.7 in there, it is going to be a minus, and the 0.9 is going to be a plus. All right, so it is going to be a minimum. All right, so anyway, f of 0 is 2.2 in decimal. F of 6 is 3.16, and f of 0.87 is 2.12. Okay, so this truly is our minimum value. which means our answer in all words here, Jane should land her boat .87 miles down the shore from the point nearest the boat. Okay, whew. That was kind of a rough problem, and the hardest part really was just finding that equation. Once we did that, yeah, you got to take the derivative, no big deal. But you know, and again, don't forget to test the endpoints if it's closed interval equation. All right, let's move on to the next one. That's probably, this first one here was probably the roughest one of all of them. All right. Okay, 21, inscribing rectangles. A rectangle is to be inscribed under the arch of the curve y equals 4 cosine of 0.5x from x equals negative pi to x equals positive pi. What are the dimensions of the rectangle with the largest area, and what is the largest area? All right, so we've done a few of these problems already. So this is 21. We've done a few of these problems here, and our equation looks something like this. Yeah, it's not a very good picture. But here's the rectangle. It should be a little bit bigger over there. All right, and this is our xy coordinate. And the equation is y equals 4 cosine of 0.5x. All right, and so what we're trying to do is we're trying to maximize the area of this rectangle. So area of the rectangle is x, x, and y. We've done this already too. So it's going to be 2x times y. And then of course we have y solved here, so a sub x equals 2x times 4 cosine of 0.5x. Okay, so simplify that. A sub x equals 8x cosine of 0.5x. All right, and again, we're trying to maximize the area, so we're going to take the first derivative, a prime of x, and we're going to use the product rule, so 8x times negative sine of 0.5x times the inside of the chain rule, so times 0.5. Okay, plus cosine of 1/2 second times derivative of the first times 8. Okay, so a prime of x equals, multiply all that out, and we get negative 4x sine of 0.5x plus 8 cosine of 1/2 x. All right, and then of course, you know, x is between negative pi and positive pi. Now that's kind of brutal to find roots with that. If you actually graph that equation, or if you graphed the derivative equation, and personally what I would do is I would you could graph this one, or you could graph the original equation, this guy right here, 8x cosine, and then use n deriv. Remember, it's going to be y1 comma x comma x. All right, so however you do it, but basically you're going to find your zeros, and of course if your n deriv is going to be your zeros are going to be your maximum minimum point, and you're going to have 2 points here that you're going to find. X is equal to negative 1.7207 and 1.7207. All right, and this, you don't want a negative value anyway here, but this one actually goes from negative, when you're doing your interval testing, at negative to positive. Okay, which makes it a minimum, and I don't want that. Okay, but this one actually goes from positive to negative, which means it is a maximum point. All right. So we're going to use that one. Let's find our y value here, because that's what we're looking for. So y is equal to 4 cosine of 0.5 times 1.7207. So y comes out to be 2.6087. All right, and y is the height of this triangle. So that's the height. And the width is just 2 times x, right? So 2 times 1.7207, because you got x and x, and so that equals 3.4414. All right, that's your width. Okay, and then your area, of course, kind of fitting everything in here, but area is equal to length times width. So 2.6087 times 3.4414. So area equals 8.9776. All right, that wasn't actually too bad. And again, that's just, there are a lot of inscribed rectangles we've had underneath curves, and really not too bad problems. Just have to kind of put it all together, okay? And, don't forget, this one's a calculator problem. The reason it was a calculator problem is because of a nasty equation for a derivative. All right. Okay, number 25 is minimizing average cost. So here's your cost function. And actually there's a typo in the book, and it's on the assignment guide. It's x cubed minus 10x squared. Instead of minus 30x, it should be plus 30x. Okay, so we'll just kind of go with that. And so anyway, that's our cost, and it says where x is measured in thousands of units. And then we want to, is there a production level that minimizes average cost? So it minimizes the average cost. Well, guys, this is just the cost. Well, how do you find the average of something? Well, don't you divide it by the number of items? So my average cost, we'll call that a of x, is really x cubed minus 10x squared plus 30x divided by x. Okay, and let's simplify that. So you have x squared minus 10x plus 30. And we're trying to minimize that. So take the derivative. We have 2x minus 10 equals 0. So 2x equals 10, x equals 5. All right, we do our interval testing here. So 4 and 6, and we plug it back again into the derivative, and we get minus and plus. So of course that makes that a minimum. And remember, x is in thousands of units, so we're going to produce 5,000 units, okay, to minimize our average cost. All right, not too bad. Okay, number 27, it's a tour service. You operate a tour service that offers the following rates. Okay, well, the first thing they give you is the revenue. And the revenue says it's $200 per person if 50 people, which is the minimum number to book the tour, go on the tour. So it's basically $200 per person, and we're doing an individual person first, okay? And then it's going to be, the second thing says, for each additional person up to a maximum of 80 people, the rate per person is reduced by $2. So it's minus 2 times, and it's over, the minimum is 50 people, so it's x minus 50. Okay? And just kind of looking what this says here, let's say 50 people went on the tour. That'd be 200, so this is 50 people. It'd be 200 minus 2 times 0, so everyone pays $200. If there's 51 people, it'd be 200 minus 2 times 1, right? 51 minus 50 is 1. So that means everyone has to pay $198. All right? Now, the only thing you have to worry about here, math fans, is that's for an individual person, and you got to multiply it by x to give you the total revenue. Okay? So that's what the revenue is. And let's actually simplify that a little bit. I'm going to do 200 because we're going to have to simplify it anyway. So 200 minus 2x plus 100. So it's x times negative 2x plus 300. And then distribute that. So I get my revenue, let's write it out here again, revenue is equal to negative 2x squared plus 300x. Okay? And then we have our cost. And it tells you the cost, it's a fixed cost, which is the $6,000. So $6,000. And plus $32 per person, so plus 32x. And that's actually pretty easy. And again, you don't need to multiply this by x because that 32x actually says, hey, number of people, you multiply it by 32. And then, for example, the fixed cost could be like a bus, right? Just to bring the bus out there, it's $6,000, and then maybe to feed the people, a little bit of gas, a little bit more gas, so you multiply it by 32 to figure the total number for all the people. All right, so what we're trying to do here is we're trying to maximize profit. So we're trying to maximize profit. So what we're going to do is we're going to look at our profit is equal to revenue minus the cost. Okay, so we're going to call that P of x, and it's going to be our negative 2x squared plus 300x minus, in parentheses, 6,000 plus 32x. Okay, let's move this down a little bit. And so we're going to get P of x, if I simplify this, or distribute the negative first, negative 2x squared plus 300x minus 6,000 minus 32x. So P of x is equal to negative 2x squared plus 268x minus 6,000. Okay, again, we're trying to maximize profit, so I take the derivative. P prime of x is negative 4x plus 268. Set it equal to 0, so 4x equals 268 divided by 4. X comes out to be 67. Now here's the deal, math fans. I have endpoints now, don't I? Because you can have a minimum number of people is 50, you can have a maximum number is 80, and the one we're looking at is 67. Okay? So make sure you check the endpoints. And this is our profit now. So it's P of 50. If I plug that in again into the original equation, so we're going to plug it into this guy right here, the P of x, and you get 2,400. P of 80 gives you 2,640, and P of 67, our relative max, is 2,978. So definitely we have the maximum value at 67. So our answer to this question is 67 people go on the tour. Go on tour to maximize profit. Okay, let's try number 31 here. Okay, 31 is we're constructing cylinders given different rectangles, or basically given a different rectangle. So let's compare the answers to the following two construction problems. A, it says a rectangular sheet of perimeter 36 centimeters and dimensions x centimeters by y centimeters is being rolled into a cylinder as shown in part A of the figure. What values of x and y give the largest volume? All right, so I'm not going to draw the pictures because you have them all in front of you, and it just takes up a lot of room here. But basically what you have is your perimeter is equal to 2x plus 2y, and that equals 36. So I'm going to solve for y. So I get y is equal to 18 minus x. And your equation for volume of a cylinder, volume equals pi r squared, right, the area of the base, times the height. So we're trying to maximize this. All right, so first of all, they give you the circumference is x. So circumference equals x, and the circumference of a circle is just 2 pi r. So if I solve for r here, to be able to substitute, I'm trying to substitute x and y into here, math fans. Okay, so if I solve for r, I get r is equal to x over 2 pi. So I'm going to substitute that into that, and I get v is equal to pi times x over 2 pi squared, and then our height is the same thing as y. They're identical, just one referred to y, one referred to h. But I can substitute that in, but instead of using h or y, I'm going to use 18 minus x here. So times 18 minus x. Okay, and let's simplify things a little bit. So it's pi x squared over 4 pi squared times 18 minus x. Okay, and if I distribute, I get v is equal to 9x squared over 2 pi minus x cubed over 4 pi. Okay, just make sure you simplify correctly. And that's really my volume equation in terms of x, so I'm going to call it v sub x. And I want to maximize this, so I take the derivative. So v prime of x is equal to, I can do the quotient rule, but I'm not going to because it's just a constant on the bottom, right? So it's really going to be 18x over 2 pi minus 3x squared over 4 pi. And if I simplify that, I get 9x over pi minus 3x squared over 4 pi. All right, that's pretty easy. And I set that equal to 0. So I move things over. Let's do our work up here now. I get 9x over pi is equal to 3x squared over 4 pi. Okay, and actually the pi's cancel out here, and we get 9x equals okay, so the pi's cancel out. Now I can cross multiply, so I get 9 I get 36x is equal to 3x squared. Okay, and I guess I could have factored earlier because that doesn't really matter, I guess. I don't know. 3x squared minus 36x equals 0. So 3x times x minus 12 equals 0. So x equals 0 and x equals 12. All right, x can't be 0 because if x is 0, it doesn't make sense. You have a 0 value for a measurement. So that's out of there. And 12 is my number. If I check it with interval testing, I do get a plus and I get a minus, which means that is a maximum value. And so that x value is one dimension, so x equals 12 centimeters. And then y is just plugging it back into the top equation there, y equals 18 minus 12, which is 6 centimeters. Okay, so those are your two answers. So let's do 31B. 31B is actually a little bit easier. It's just not as complicated here. Okay, 31B is the same sheet is to be revolved around one of the sides of the length y to sweep out the cylinder as shown in part B of the figure. What is the value of x and y will give the largest value? So it's the same thing. Perimeter of that rectangle is 2x plus 2y, and that is again equal to 36. So y is the same thing, 18 minus x. All right, same deal. Volume equals pi r squared, which is x squared. Now that's what r is, times the height, which is y. And we're trying to maximize that. So that's why this is a lot easier, because it's just that rectangle being revolved around. All right, so again, let's substitute that y into here. So v is equal to pi x squared times 18 minus x. So v of x is equal to 18 pi x squared minus pi x cubed. So v prime of x is equal to 36 pi x minus 3 pi x squared, which equals 0. I factor out a 3 pi x, and I get 12 minus x equals 0. So 3 pi x equals 0, and 12 minus x equals 0. So here x equals 0, here x equals 12. Again, I can't have a 0 for an answer. So I again check my interval testing here with 12, 11, and 13. I'm trying to maximize it. So, and I plug it back into the derivative. I get plus and I get minus, so it is a max. And so it's the same thing. Plug it into, so 12 is my x, so 12 is one dimension. That's x. And then y, of course, is the same thing, 18 minus 12, which is 6 centimeters. All right, so the whole problem says compare the answers to the following two construction problems. The answers are the same. All right, that's the comparison. Okay, last one here, number 41. We're almost done, math fans. It's a little calculus and geometry. Sweet. How close does the curve y equals the square root of x come to the point 3/2 comma 0? Hint, if you minimize the square of the distance, you can avoid square roots. Okay, so this is the deal. You have y equals the square root of x, and you're saying 3/2 comma 0 is, how close does this come to 3/2 comma 0? All right, well, if I actually kind of compare, I'm saying how close does it come to x comma the square root of x? Okay, because that's what this is, right? Isn't that what y is? Y is the square root of x. So I want to know how close does it come to that? And they even give you a nice little friendly picture here too. And so if you minimize the square of the distance, so minimize d squared, and isn't d is equal to the square root of x minus 3/2 squared plus the square root of x minus 0 squared. And since I'm minimizing d squared, well, it's squared. So we get d squared is equal to, just the square root goes away, and we have x minus 3/2 squared plus the square root of x squared. All right, and we're minimizing this. Okay, so what I'm going to do is I'm going to minimize. By minimizing that, I need to FOIL this all out here. So I'm just going to call this d of x, because that's what's going to happen when I'm going to minimize. Instead of saying d squared, it gets too complicated. I'm going to minimize just d of x, which is d squared. All right, but anyway, if I FOIL this out, I get x squared minus 3/2 x minus 3/2 x, which is minus 3x plus 9/4 plus x. So d of x is equal to x squared minus 2x plus 9/4. And then it's d prime of x to find the the minimum value, right? So 2x minus 2, set that equal to 0, and x comes out to be 1. And if I actually do my interval testing, 1, and I put 0 and 2 here, it gets negative and positive, so this is a minimum value. And so that's it. X equals 1, y equals the square root of 1, which is also 1. Okay? So the whole question is, how close does it come? So basically what I do is I plug it back. I'm looking for the original problem, which was D, and I don't have, it's kind of here, right? This was the original problem. D is equal to the square root of x minus 3 halves squared plus the square root of x squared. That's the original problem. And so if I plug that value of x into there, I get, running out of room, D is equal to the square root of 1 minus 3 halves, which is negative 1 half, squared, plus, if I put a 1, plus that's just 1. The square root of 1 squared is 1. So I have D is equal to the square root of 1/4 plus 1, or the square root of 5/4, and simplify it, it's square root of 5 over 2. That's my final answer. It was kind of a weird problem, but it's, just kind of follow with their, the little hint there, and you're minimizing that, the squared. And the only reason they even say that is because you can avoid some of the square roots, which makes it a lot more complicated. All right. So minimizing the actual problem is the same thing as minimizing the squares. All right, math fans, that's it for day 2 homework. Hopefully this helped out. Talk to you later. Adios. Goodbye.